There are certain angles that show up repeatedly when working with trig functions. In this video, I'm going to show you 3 different ways that you can find exact values for some of these special angles that will show up a lot. Please make sure to take notes in your notebook. I should have mentioned on the intro slide that all 3 of the ways I'm going to show you will give you the same answers, and so you only need to be comfortable with one of the ways. You don't have to know them all. So I'm just trying to give a few different ways so that you can choose the one that makes the most sense to you. The first one that I'm going to use involves special right triangles. And so first we should review the relationships between the sides and angles in these special triangles. So first we'll look at the 30, 60, 90 triangle, and so that missing angle is 90 degrees. And across from any smallest angle in any triangle will be the smallest side. So we're going to focus on the side opposite the 30-degree angle, and I'm going to label that side as S. And if you remember, if in a 30, 60, 90 triangle, your side opposite the 30-degree angle is S, then the other 2 sides will now have to be in a special relationship with that first side. So across from the 60-degree angle will always be that first side, S, times root 3. And across from the 90-degree angle, the hypotenuse, will always be 2 times that smaller side, S. Now, this is supposed to be about trig functions, so let's start by focusing on sine. I'll work with the 30-degree angle first. And so if we wanted the sine of 30 degrees, sine is always opposite over hypotenuse. And so in that case, the sine of 30 degrees would be S over 2S. And using some simple mathematics here, if I reduce out the s's, I end up with the sine of 30 degrees equaling 1/2. By making the sides of my triangles in terms of s, that means that the triangle could be any size. As long as the angles are 30, 60, and 90 degrees, the sine of the 30-degree angle, regardless of how big s is, it could be 5, in which case this would be 10. It could be 20, in which case this would be 40. The sine of 30 degrees will always be opposite over hypotenuse, which will always reduce down to 1/2. So in short, the sine of 30 degrees is always 1/2. Now let's continue with sine, and now look at the 60-degree angle. So if we're at the 60-degree angle, sine is still always opposite over hypotenuse. So in this case, that would mean sine of 60 degrees would be s root 3 over 2s. Now remember, s can be any length. The s's, again, would reduce out, and so no matter what size the triangle is, as long as the angles are 30, 60, and 90, the sine of 60 degrees will always reduce down to root 3 over 2. And in fact, sine of 60 degrees is always root 3 over 2. At this point, you should now try using the same method that I've been using to find the cosine of 30 degrees. Okay, so first you can stand here and remember what cosine is, and then find the cosine of 60 degrees. So make sure you write those down in your notebooks. I'm going to move on to the other special right triangle, which is the 45, 45, 90 triangle. And hopefully you remember that in this triangle, the 2 sides, since the 2 angles are the same, the 2 legs will have to be the same. So if I call this side S, then this side across from the other 45-degree angle will also have to be S. And across from the 90-degree angle will be S root 2. If I wanted to find the sine of 45 degrees, the exact value for the sine of 45 degrees, again I would do opposite over hypotenuse, and that would give me sine of 45 degrees is S over S root 2. Again, the s's would reduce, and we get 1 over root 2. But if you remember, we're not supposed to leave radicals in the denominator, so when we rationalize that, we would end up with root 2 over 2. And the sine of 45 degrees is always root 2 over 2. And if I now find the cosine of 45 degrees, so you can stand at either angle, the cosine of 45 degrees would be adjacent over hypotenuse, and you can see that it turns out to be exactly the same. So the cosine of 45 degrees would also be S over S root 2, And when I do all of the simplifications, I would end up with the cosine of 45 degrees being root 2 over 2. So both sine and cosine are equal when at 45 degrees. I haven't done tan, and so I'd like you to go back to both triangles now and figure out the tan of 30 degrees, 60 degrees, and 45 degrees, and write that in your notes as well. So to summarize, the first method that I'm showing you for finding the exact values is to use special triangles. So if on a quiz I ask you what is the sine of 30 degrees or the cosine of 60 degrees, you could quickly write down the triangles, and then you could fill in the special sides. It might be easier, instead of the s root 3, to just leave them as across from the 30-degree angle 1, and then this would just be 1 root 3, which is root 3, and this would be 2 times 1, which is just 2. And so, as you can see, if I look at sine of 30 degrees, it's still 1/2. Cosine of 30 degrees is root 3 over 2, and so on. And if I go to the 45, 45, 90 triangle, instead of 1, 1, and root 2, to avoid the rationalizing problem, if you make the two sides root 2, okay, they're still equal, and the hypotenuse 2, then when you go to do the sine of 45 degrees, for instance, you get root 2 over 2 right away, and you don't have to rationalize. So this is one way. You could quickly write these triangles down, and then you'd be able to evaluate the different trig functions. The one problem with the special triangle method is that it doesn't help us with the two remaining angles that are special, which are 0 degrees and 90 degrees. So in the next method, I'm going to show you how you can quickly write them in a chart with a little pattern. You probably recognize with the special triangles that a lot of the exact values are over 2. So actually, that's how we're going to start this. Each of these I'm going to put over 2, like so. And then the trick is that you start with cosine, if you're doing cosine first, which I am in this table. Cosine starts high at 0 degrees. It's the largest it can be, which I'm going to put root 4, which might seem crazy because root 4 is actually 2. And then you just decrease as you go to 90 degrees. So root 4, root 3 over 2, root 2 over 2, root 1, which is 1 over 2, and root 0 over 2, which is 0. So if I simplify these, this top one would be 2 over 2, which is 1. Root 3 over 2 remains root 3 over 2. You don't have to rewrite it if you don't want. Root 2 over 2 remains root 2 over 2. Root 1 over 2 is simply 1/2, and if you remember from the special right triangles, the cosine of 60 degrees was 1/2, so it's lining up nicely. Cosine of 60 degrees, 1/2. And then the cosine of 90 degrees is, when you reduce this, 0. The key to this method is remembering that cosine starts at its largest value. So at 0 degrees, cosine is the largest it can be, 1, and then it decreases from there to 90 degrees. Sine does the opposite, basically. So it's going to start low and then get bigger. If you mess that up, you're in trouble. So let's now do sine. It's the same exact thing. All of them will be over 2. And then we're going to start low. So root 0 over 2, root 1, root 2, root 3, and root 4. Or you could take the cosine column that's already been simplified and just go from the bottom up. Either way, you get 0, 1/2, root 2 over 2, root 3 over 2, and 1. And so those are the sine special angles. Finally, on to tan. Tan is a little more complicated because it involves the values for sine and cosine. In fact, and this is really good to know, tan is always sine of theta, or just sine over cosine of theta. It's always sine theta divided by cosine theta, just sine over cosine. And now that we have the table, we can just use the values from it. I'm just going to do 0 over 1 because the tan of 0 degrees will be sine of theta at that angle over cosine of theta at that angle. So it'll be sine of 0 degrees over cosine of 0 degrees, which is just 0 over 1, or 0. The tan of 30 degrees will be the sine of 30 degrees, which is 1/2, over the cosine of 30 degrees, which is root 3 over 2, or it will be 1/2 over root 3 over 2. Now it's a little complicated. That reduces down, those 2's will cancel to 1 over root 3, which when you rationalize will be root 3 over 3. The next one, tan of 45 degrees, will be sine of 45 degrees, root 2 over 2, over cosine of 45 degrees, root 2 over 2. And so root 2 over 2 over itself, any number divided by itself, is always 1. So the tan of 45 degrees is 1. That's a great one to know. Tan of 60 degrees will be sine of 60 degrees over cosine of 60 degrees. And when you do the simplification, it will work out to be root 3 over 1, or just root 3. Because again, the 2's in the denominators will cancel. And finally, this one's really interesting. The tan of 90 degrees would be the sine of 90 degrees, which is 1, divided by the cosine of 90 degrees, which is 0. And we've talked many times this year about the fact that you cannot divide by 0. It is undefined. So the tan of 90 degrees is undefined. It is not 1. It is not 0. There's the table method. It looks a little messy at this point, so you might want to recopy your simplified version with all of your final answers. But the way to recreate it, if you wanted to, like on a quiz or a test, you could just quickly write down these 3 columns and fill them in using the shortcut. On to our final method. This method uses your hand, so you don't even need paper for this. This is my husband's hand, by the way, in case you thought I had very manly hands. The fingers on the hand are actually representing the angles. So if I draw in here, you can pretend this is our x-axis here. This would be 0 degrees, okay, from the x-axis. This next angle up would be 30 degrees. This next angle up would be 45, would be halfway between. So 45 degrees, and then 60 degrees, and finally 90 degrees would be at the top. So here are the different angles. There are 2 things you have to remember in order for this method to work. The first is that cosine is high, which should make sense because cosine started with its highest value, so cosine is going to be at the top, and sine will be down. So the other thing is sine is down. And your finger, you're going to fold your finger for the angle that you want. Let me show you an example. The other thing you have to remember is that it's always root number of fingers over 2. Okay, I know this sounds super complicated, but actually this ends up being the favorite method for most students. So if we look at our finger that's folded here, if I draw in my angles again, remember this was 0 degrees, so folded is this angle, which is 30 degrees. Okay, so if I wanted the cosine of 30 degrees, I told you to remember that cosine was up. So all you have to do is count the fingers above your folded finger. That's 1, 2, 3. And it's always root number of fingers over 2. So the cosine of 30 degrees would be root 3 over 2. If I do the sine, I can do the sine at the same time here. The sine of 30 degrees, you have to remember that sine is down, the fingers below. There's 1 finger below. So sine would be root number of fingers, root 1 over 2. That's for 30 degrees only. Okay, so that's because that's the finger that was folded. Let's try another one. Here you can see that the angle, or the finger that's folded down, is at 45 degrees. So we're finding the sine and cosine of 45 degrees. If I wanted to find the cosine of 45 degrees first, doesn't really matter which order you do them. Cosine, if you remember, are the fingers above, and it's always root fingers over 2. Root 1, 2, root 2 over 2. And sine actually would be the same. If you remember from either the triangle or the table, the sine of 45 degrees is also root 2 over 2, but if you use the method, here's 45 degrees, there are 2 fingers below, which is where sine is, and so it would be root 1, 2 over 2. Now, I don't have any more pictures of my husband's hand, but let me show you another one. If I wanted to do the sine of 90 degrees, so the sine of 90 degrees, for this one, I'll write it up here, I'm supposed to count the fingers below 90, and it's going to be that number over 2, root that number over 2. So that's 4 fingers. So if I put the thumb down, I'd have 1, 2, 3, 4 fingers left up, which would be root 4 over 2, which is 1, and the sine of 90 degrees is 1. And it would work for all of the other ones. In fact, if I wanted to do cosine of 90 degrees, for the cosine of 90 degrees, there are no fingers to the left. There are 0 fingers above the 90 degree mark. And so the cosine of 90 degrees would be root 0 over 2, which is 0. Those are the 3 methods. Tan, for this method, you could do by finding first sine and cosine and doing sine over cosine. I hope you found this video helpful, and of course I'm available to answer more questions in class or online.